interval notation, just like I just said, just lets us write a group of numbers all at once. So it lets us write a group of numbers without having to list everything. Now, you've done this before. You did this back in Algebra 1 and Algebra 2 when you had inequalities that you were solving, and you might have had a number or an equation that came out and had an answer of everything greater than 4. And you didn't list every number greater than 4, right? You just used an inequality and said x was greater than 4, and then they had to draw that pretty little number line and you shaded it in. Yeah, so we're going to take that idea and we're going to simplify it even more, because we're big bad mathematicians and we don't want to have to draw number lines, and it's just a pain in the butt. So we're going to take that and simplify it even more. So the easiest way for you to kind of get used to this is to look at those graphs and then transfer those graphs to be interval notation. So just in case your summer cobwebs are still on, do you remember what sign that is?
Less than. That's backwards now.
Greater than. Whew, good thing we're writing this down. Greater than. Greater than. If I put a line under it, it's greater than.
Or equal to.
Beautiful. The one that kind of almost looks like an L, that's my less than. And a line under it gives me less than or equal to. So now that we dusted that cobweb off, what if I said graph -1 is less than x, which is less than 3 on a number line. So the first thing I would do is draw my straightest possible line, right? Maybe just for a reference, I'm going to put 0 in the middle. Then I know I need a -1 on here, and I need a 3. If you want, you can put all the numbers in between, but you don't have to. I'm hoping at this point in your math career, you know that 1 and 2 are in between 0 and 3, so you don't actually have to prove it to me anymore. And then it gets a little tricky, because then I have to remember, do I want an open circle or a closed circle? Okay, so greater than means I can have every number bigger than -1. Greater than -1 means numbers greater than -1, numbers bigger than -1, but I can't have -1. So that's why I use an open circle on there, because I can get really, really close to -1, but I can't actually physically have -1. Yeah. When I have that equal to, if I can actually have -1, then I shade it in, because then I can include it. That circle just tells me I can get really close to it. So I can get really close to -1. I can get really close to 3. And since my x is in the middle of those two, I want all those numbers in between now. I want numbers bigger than -1 and smaller than 3. That's all these in here, right? Is it all coming back to you? Kind of, maybe, sort of. What if I asked you just to graph x is less than or equal to 4 on a number line. So then I draw my number line. Got a 0. Got a 4. 4 is bigger than 0. Look at me, crushing it. And then now I need to decide open or close circle. Close, because I can include my 4. So I'm going to close my 4. And if I want numbers smaller than 4, I'm going to shade to the left. Right? And this was always a good time in algebra. But we're not really looking at your drawing skills. We got serious math to solve, so we don't have time to be doing this. So we're gonna scrap this idea, and we're gonna go with a faster, more efficient way that does not require you knowing your left or your right, or having to shade anything or draw straight lines. It's gonna be good stuff. So we call this interval notation. An interval notation lets me take a group of numbers. So say I want to go from 0 to 20. And if I want to go from 0 to 20, I just go 0, 20. And if I want to include 0, I use a bracket. If I don't want to include 20, I use a parenthesis. So this means include 0. This means don't include 20. And I can mix and match them however I need them. So if I want to include both of them, I could use brackets on both sides. If I don't want to include either of them, I can use parentheses. I'm always just going to take my first number, my smallest number, comma, my biggest number, and then I'm just going to decide either bracket or parenthesis based on if I'm including them or not including them. So if I was going to write that down in an organized way in case I forgot later, the easiest way for us to do this is kind of to make a chart. So we can have a type of interval. We can have our actual interval notation. And we'll draw it as a graph just so that we can see it in a way that we know. I'm going to try to draw a really straight line. Oh, geez. That was stressful. Oh, man, it's even less straight up there. Dude. So let's see. My first one I can have, we call this an open interval. And an open interval is just like when I have my open circles. I'm not including those numbers on the end. So if I was going to have an open interval from 0 to 4, I just use parentheses. And this is the same thing as if I were to say to go from 0 to 4 and have everything in between but not including 0 and not including 4. So that's our open circle graph. And when we don't include things, we just use the parenthesis. Then I can have a closed interval, just like I can have a closed circle, and my closed intervals are going to use my brackets, 0, 4. The hardest part, I think, about this is if you don't have good handwriting, it's hard to make your parentheses and your brackets look different. But parentheses rounded, brackets kind of squared off. These are my closed intervals, so they would be my closed circles. So I would say from 0 to 4, everything in between. Then we're going to get really fancy. Use purple because I can have a half open interval. And my half open interval is just going to be a combination of the two. So I could not include 0, but I could include 4, which would look like this. Or I could include 0 and not include 4. So I can mix and match any way I want in order to show what I'm doing, in order to show which numbers are actually being included or which numbers aren't being included. So a few tips for your success. Anytime we're dealing with something that's going to an infinity, you're always going to use a parenthesis, because the whole concept of the idea infinity is that it's a number we can't ever get to because I can keep counting forever and ever and ever. I can get a little bit bigger, a little bit bigger, a little bit bigger. So because I can't ever get there, it's something that I can't include, so it's a parenthesis. So any infinity, our fancy symbol for infinity, is always a parenthesis. You're also always going to put the smaller number first when you're writing your interval. So the smaller number always comes first. And this just lets us keep our work a little bit organized, just like we wouldn't count 1, 4, 3 randomly. We count in order, so we want to make sure our intervals are in order. So let's see, problems you're going to see today, because I know that's what you're really looking for. You're like, give me the math, lady. So I could ask you to graph the inequality and write the interval. I'm going to ask you to do both, just because I think it's easier to look at the graph and draw the interval. Moving forward, we won't have to draw the graph anymore. We can just write the interval, but I don't want to mess with your brain too much on a Monday. So if we look, graph the inequality and write as an interval. So the first one I'm going to give you, we've already graphed this one. -1 is less than x is less than 3, right? We had that pretty graph that had a -1, it had a 3. They both have open circles because they're just less than signs. And it was all my numbers in between. My x is in between -1 and 3. So if you were going to write an interval for this, I like to first pick out my two numbers and then go back and do my parentheses and brackets. So I look at it and I say, okay, I'm going from -1 to 3. I'm not including -1, so I get a parenthesis. And I'm not including 3, so that also gets a parenthesis. And now I'm done. So first I pick out my numbers, then I pick out my parentheses or my brackets. I mean, feel free to do it however which way you really want. But I think it just makes it a little bit easier that way. What if I went -6 is less than or equal to x, which is less than or equal to -1/2. So when I go in, I'm going to draw it. I need a -6 and a -1/2. They're equal to's, so I'm getting my closed circle. Closed circle. My x is in between, so I shade in between. And now, from looking at that, I can see my interval starts at -6. It ends at -1/2. I'm including -6, so I get a bracket. I'm also including -1/2, so that also gets a bracket. What would you do in a situation where its x is greater than -2, where now you only have one number? Graphing it is a little bit easier, right? Because you're just putting one number on your graph, a -2. It's a greater than symbol, so it's just an open circle. And you just keep shading to the right. So now I only have one number though when I go to write my interval. I see that my interval starts at -2, but it doesn't ever stop, right? So this is where my infinities come in. So because it never stops, because I don't have another number, I'm using an infinity, which is like a sideways 8 basically, or two circles next to each other. Now I'm not including my -2. And I'm remembering that I just wrote down that infinities always get parentheses, so I know that my infinity also gets a parenthesis. All right, last one. What if x is less than or equal to 4.5? So I know I want 4.5 on my number line. Beautiful. I'm going to color in my circle because it's an equal to. It's less than, so I want numbers to the left. Now when I go to write my interval, where does my interval start?
Negative infinity?
Yeah, negative infinity, because it's going back forever, so this way is negative infinity. Forward forever is positive infinity, backwards forever, negative infinity. So my first number in my interval is going to be negative infinity. The second number is going to be 4.5.
So even with a negative infinity, still.
It goes first, yeah. So negative, because even though it's an infinity and we think infinity really, really big number, it's a negative, so it's a really, really, really small number. So that comes first. And then 4.5, I have an equal to sign, which gives me a bracket. What are we thinking? Not bad? All right, I know I said that was the last one, but you guys are just geniuses. So what if I said, all right, here's a challenge. What if I said x is less than or equal to 2, or x is greater than 3? X is less than 2 or greater than 3. So, draw my arrow. So I've got a 2. I've got a 3. All right, x is less than 2. A less than sign, less than or equal to 2, tells me closed circle, right? And less than 2 goes to the left, right? X is greater than 3 is going to go this way to the right. So now I have kind of two sets of numbers. I have two groups of numbers, right? I don't have everything in between 2 and 3 like I had before, but I have all the numbers less than 2. I have all the numbers greater than 2. So the cool thing about an interval is I can write as many intervals as I want. I'm just going to keep listing them as I need them. So I know from the last example that when I go back to the left, that really means negative infinity, right? And when I go on forever, this means infinity. So I have two separate intervals here. I have an interval from negative infinity to 2, and I have an interval from 3 to infinity. So I have a parenthesis on my infinities because they always get in parentheses. My
Bracket parentheses.
perfect. And then if I want to be even more mathematical, to combine these, I can put a comma, or I can put a U for union, or it's like a math symbol for and. So you can put a comma, you can just list them, or you can be super fancy and really scare the freshmen if they see your notebook and put a random U in the middle for union of the two. Sounds good? All right, you guys rock.